Okay, so we're going to continue on with this problem now that the bell hasn't interrupted us. So write the equation of a line tangent to the graph of x squared minus y cubed equals 0 through the point 1, 1. So even without having to do a lot of work, I can already write y minus something equals something times x minus something. I know I need an x and a y value and my slope. So I have x and y right here in my point 1, 1. So I know y minus 1 is equal to our slope times x minus 1. We need our slope now. Our slope is our dy over dx equation. So we have dy over dx is equal to 2x divided by 3y squared. We need to plug in our x and y. So dy over dx evaluated at xy equals 1, 1, 1. So 2 times 1 divided by 3 times 1 squared. So 2/3. So I know my slope is 2/3, and our equation y minus 1 is equal to 2/3 times x minus 1. And I can leave it just like that. Okay, now we have find dy over dx given that 3x to the fourth plus sine y minus y squared equals cosine of x. So we are going to take the derivative. The derivative of 3x to the fourth is 12x cubed. The derivative of sine is cosine, and we keep the inside the same, times the derivative of the inside, minus the derivative of y squared, so 2y to the first times dy over dx equals the derivative of cosine, so negative sine of x. Okay, so we are going to move anything that doesn't have a dy over dx over to the other side. So we want our dy over dx's to be on one side, everything else on the other. In this case, we're going to go ahead and subtract 12x cubed from both sides to get cosine y dy over dx minus 2y dy over dx equaling negative sine x minus 12x cubed. We need to get these two dy over dx's to be one dy over dx. So what we're going to look at is what do they have in common between these two terms. Well, these two terms have dy over dx in common. So what we're going to do is factor out dy over dx from both things. If I do that, I'm going to be left with cosine y minus 2y, which is equal to negative sine x minus 12x cubed. Now that I have 1 dy over dx times some other stuff, we're going to go ahead and divide both sides by everything inside those parentheses. So dy over dx is equal to negative sine x minus 12x cubed divided by cosine y minus 2y. I am going to leave it just like this now that dy over dx is by itself, and we're done with the problem. So our steps here are really take the derivative of everything, move dy over dx to one side, everything else to the other, factor out the thing they have in common, and then divide by what we need to divide. So find dy over dx given y squared plus 2xy minus 3x equals 4. So derivative, so we need 2y dy over dx plus. We have 2 times xy, so we have a product rule here. So we're going to make u equal to x. We're going to make v equal y. So the derivative of 2x is 2 times v plus the derivative of y times 2x, so 2x dy over dx minus the derivative of x cubed, and it's equal to the derivative of 4, which is 0. I'm going to move everything that's not dy over dx to the other side, so 2y dy over dx plus 2x dy over dx is equal to 3x squared minus 2y. We have a dy over dx times 2y, a dy over dx times 2x, so I'm going to factor out the dy over dx. to get dy over dx times the quantity 2y plus 2x. And then we're going to divide by that quantity. So dy over dx is equal to 3x squared minus 2y over 2y plus 2x. Our last one here, we have the derivative of x cubed minus x times y plus y cubed. So something kind of similar. We have 3x squared, the derivative of xy. I'm going to keep the subtraction with x to make sure I don't miss out any signs. So the derivative of negative x is 1y. The derivative of y times negative x is negative x, or minus x. Dy over dx, the derivative of y cubed, 3y squared, dy over dx, and the derivative of 0 is 0. So now what we're going to do is, just like we did before, move everything that's not dy over dx to the other side. I'm going to move some stuff around so that way our negatives are kind of not in a weird spot. So 3y squared dy over dx minus x dy over dx equals y minus 3x squared. We have our dy over dx's, so I need to factor them out. And then get dy over dx by itself. When we're doing this, the biggest thing with implicit differentiation is remembering that multiplying by dy over dx, and then it's just practicing it.